So yeah, the assignment is technically still open. So if you want to, you can still submit it. It's open until Sunday. It will mark it late. Yeah, just try it again. Um, like I said, if you can't get it to work, just send me an email of the file, and that works too. It's kind of annoying for me to look at all the things. No, I won't take off any points for being late. Um, but if you do it after Sunday, then yeah, I'll start marking them late. No, I won't take off points. I won't mark it late in the gradebook. Yeah. Okay. Sorry, I was just checking the stream to make sure that there wasn't any lag or anything. Yeah, it's like a 2-second delay. What's up, Cooper? Yeah, so Enya, if you had a previous version of the quiz, yeah, so if you okay, so lots of questions. Hold on. So Enya, there was an error on number 10, but I corrected it. However, the way Canvas does it, it doesn't correct it if you're in the middle of doing the assignment. It only corrects it when you go to like your second or third attempt. And so now, if you look at your second or third attempt, it should be fixed. I'll don't worry about number 10. I'll give you guys enough extra credit to balance it out. So. And then Kate, your question, that's weird that it deleted your last 4 problems. Maybe that sounds like you were having internet connection issues, because it should autosave after you do every problem. And so if it didn't upload correctly to the server to say that it was autosaving, then it's going to delete your last couple questions. So if you want to do it again today, you're totally fine to go do it again today. I won't take off any points for being late. So try doing that again today. Maybe that'll help. Yeah, no. Yeah, well, especially now, I'm being way more lenient than I normally would be because of our current situation, right? Anyone who's not being lenient is kind of a jerk. So, yeah. Everyone should for sure be much more lenient with the current situation. Hey, don't knock Jimbo. I love Jim Hodges. He's my favorite. Oh gosh. Yeah, that sounds like Hodges. See, but the thing is, he's so you gotta remember that teachers will sometimes say things and then do something different. They're hypocritical, but usually in a good way, meaning that like they say they're really strict, but if you email them and ask them and talk to them, um, they are turned out usually to be a little more lenient than they present themselves to be. That's not true for everyone, but it is a common theme. Oh goodness, I love Jim. He's hilarious. Let's see. Did I say that, Cooper? Maybe I was throwing out a bunch of ideas, but I didn't know what this was actually going to look like. That's actually pretty funny, Lauren. Yeah, whatever. Yeah, I didn't know all the logistics of everything until we actually got into it. Yeah, yeah. Well, because I think I realize that there are some people that have like both their parents work and they have little siblings at home and they have to babysit their kid, like their younger siblings during the day. And since they have to babysit their younger siblings because their parents are working, it would be totally unfair of me to try to take attendance. Which is why I but that's why I post the videos to YouTube so that if people can't make class, that they can go back and watch. But my real frustration is I know there are people out there that are just like, oh, well, I'm not going to go to class. I'm not going to watch anything. I'm just going to try to do the assignment. Because I got a couple emails from people yesterday that were like, Gillespie, I have no idea how to do the assignment. I don't know what's going on. And I'm like, we literally went through half of it on Wednesday. What do you mean you don't know what's going on? So, I don't know. All right, let's stop quoting Hodges, but that does sound like something Hodges would say. I think Michaela is hinting at what's actually going on. Yeah, and so Xander, so this is actually a really good example. Xander yesterday afternoon was in the Discord and was asking questions and getting help on the homework. And it's fantastic. More of you need to take advantage of me in the Discord to help with that. I do not speak Turkish. So if you go into, like, in the afternoons, go into the Discord and go from there. Yeah, hydrochloric acid, or hydrochloric sulfide, that's not a thing. I think you mean hydrosulfuric acid or hydrogen sulfide, and it doesn't, because hydrogen sulfide or hydrosulfuric acid is a weak acid. Okay. So, Ellie, you've been using the Discord, but you need to come in during that time and come get help. You're not stupid. But if you need help, come get help. I'm available every afternoon in Discord for you guys to come get help. Yeah. So for sure, there are some of you taking advantage of using the Discord to get help, but not enough of you, not nearly enough of you, are using the Discord to get help. So make sure that you take advantage of that. Okay, I've kind of droned along on this intro. Let's get into the notes. Okay. All right, so we're gonna go Roman numeral 5. We only have 6 Roman numerals, so see, that's the thing, Matthew. You don't know which problems you got wrong. You have to kind of reevaluate yourself on the whole problem, and I did that intentionally. So, yeah. I didn't want to make it too easy for you to just submit it once and then know exactly which one you got wrong and fix it. So that's why you can always come and ask me. Okay, noon to 2 every day, Ellie. Every day it's the same thing. Noon to 2. Because I think yesterday you messaged at like 4:30 or something weird. Yeah, it was at 4:30. Hey, Cooper. Okay. Yeah, so Matthew, if you ever need extra help, make sure you ask. So the hope is that you guys do these assignments early, so that, say you get them done, Tuesday night or Wednesday night, so that, on Thursday during the day, you can get help on the problems you miss, right? Don't wait, even though the assignment's not due until Thursday, don't wait until Thursday, which I know is really hard because procrastination is real, and the urge to procrastinate is real. I feel that. But if you want help, if you're concerned about getting help and you want to get all those things right, make sure you start the assignment early so you can get help when I'm available. Okay, we do have another assignment next week, and I want to get into some of the stuff you're going to need to do that. So, solubility rules. So what we're going to talk about here with solubility rules is a couple of you guys noticed on this last worksheet that a lot of the problems produced a precipitate of something. Okay, it turns out that we actually can predict whether or not something is going to form a precipitate, and to do that we use the solubility rules. Okay. Yeah, it's not a statement, solubility rules. It's the rules for determining solubility. All right, so let's see. What do I want to call A? We'll just call A the rules. Okay. Number 1. A substance will be soluble aka aqueous, if it contains at least one of following ions. Okay, so a substance will be soluble if it contains at least one of the following ions. Let's see, what's Cooper? Cooper precipitates are always solid, but rain is stuff for precipitation in liquid. Okay, so, all right, so it's terminology. The reason why they call rain precipitation is because if you look out at rain, right, the sky, the liquid is falling to the surface. If you do a double replacement reaction, what happens is it produces a solid, and that solid falls to the bottom. And so the reason why they have the same root word is if you look at it, it looks like the same thing's happening. It looks like these solid particles are raining down in your solution to the bottom. But in this context, in this terminology, a precipitate will always be a solid. Precipitation reactions will always be solid. We're not talking about rain precipitation or snow or whatever. We're talking about mixing two solutions together and getting a solid that's going to fall to the bottom. So, yeah, that's kind of a cool study into the English language. Okay, so our ions are chloride, bromide, iodide, chlorate, perchlorate, nitrate, sulfate, and acetate. Now, with the exception of acetate, this list should look really familiar. Why does this list look familiar? Hey, Zach's got it. They're all the strong acids. Good job, Zach. Right? So chloride, bromide, iodide, chlorate, perchlorate, nitrate, and sulfate are from the strong acids. Okay, so our 7 strong acids, we mentioned the 7 strong acids as being compounds that always split. And so it makes sense that if a compound has one of the same ions as your strong acids, it's also likely to be soluble, right? Meaning it's likely to dissolve in aqueous solutions. Acetate's kind of just another random negative one. Now, for our cations, we have a similar list. It's lithium, sodium, potassium, rubidium, cesium, calcium, strontium, barium, and ammonium. Okay, so lithium, sodium, potassium, rubidium, cesium, calcium, strontium, barium, and ammonium. If you look at a periodic table, pull one up real fast, right? These are the alkali metals. Lithium, right? Alkali metals. Lithium, sodium, potassium, rubidium, cesium. Technically francium too, but francium is so rare and radioactive that we just don't bother with it. And then it's calcium, strontium, and barium. So it's the heavy alkaline earth. So the alkali metals, lithium, sodium, potassium, rubidium, cesium, and then the alkaline earth, calcium, strontium, barium. And then also our good friend ammonium, it's the only polyatomic cation, and it also forms soluble solutions. So if a compound contains either of these, or both, it's highly likely that it's going to be soluble, meaning it can dissolve in water. It's not going to be a precipitate, right? It's not going to form some sort of a solid out of solution. Now, you can, of course, always get it as a solid element if there's no water around, but if you mix a compound that has either one of these ions and you put it into water, the chances of it dissolving is very likely. Now, it wouldn't be chemistry if there weren't exceptions. Hey, oh gosh, everyone's spamming the chat. Exceptions, exceptions, exceptions. Good, you guys have learned well. You've learned well. So, okay. So exception number 1, we're going to talk about silver, lead, and mercury. So silver, lead. Let me double check something. And mercury. Yeah, specifically lead 2+. Yeah, you're right. And same thing with mercury, specifically mercury 2. Right? Turns out mercury 1 is relatively soluble, but mercury 2. Okay. So silver, lead, and mercury. Silver, lead, and mercury are insoluble, aka solid, with everything except nitrate. Yeah, so the charge is silver with a 1+, lead with a 2+, mercury with a 2+. So yeah, the idea is that these guys are they form solids. They strongly bond with everything, and so they form solids really easily, and they don't dissolve. I know, it's an exception to the exception. So the idea is that if you have silver, mercury, and lead, your compound is going to be insoluble. It's going to be solid unless it's silver nitrate, lead nitrate, or mercury nitrate. Except. Number 3. Hate to do it to you, Johnny, but we get another exception. But this is the last one, I promise. These are what I call the bad combos. Okay. Calcium, strontium, and barium. Okay. Let's see. So, oh my gosh, Cooper, stop going on a tangent. Okay, so calcium, strontium, and barium, right? We've listed calcium, strontium, and barium as our soluble cations. So calcium, strontium, and barium, with almost everything, is going to be aqueous. But there are a few notable exceptions, and those are phosphate, carbonate, and sulfate. And so if calcium is paired with phosphate, carbonate, or sulfate, it will be solid. If strontium is paired with phosphate, carbonate, or sulfate, it will also be solid. And if barium is paired with phosphate, carbonate, or sulfate, it will be solid. So these compounds, these combinations are insoluble. Solid. Okay, and that's it. That's all you gotta know. Okay, so these are the rules. This is going to be an important thing to reference every time that you do a double replacement reaction. So if you're ever going to do a double replacement reaction, you're going to need to understand this idea. So I don't know if you guys have noticed this, but we've been doing these notes over the past couple of weeks. On Monday, we talked about how for a single replacement reaction, you have to check if the replacing element is more reactive. For a double replacement reaction, you have to check when they swap if one of the new compounds that's formed is insoluble or solid. So the notes we took on Monday are if you have a single replacement reaction. These notes are going to be useful for double replacement, which we're going to get into here in a second. I'm going to do kind of an example. Okay, so make sure everybody has got these ideas down. So let's do letter B. Examples. Let's say silver nitrate and sodium chloride solutions are mixed. Okay. Parker, you really have 10K? I thought it was going to take a little bit longer for people to get up to 10,000. All right, so first example. Silver nitrate and sodium chloride solutions are mixed. Okay, so what we're going to do is we're going to write a reaction that describes this problem. Okay, so let's write a reaction. Okay. All right, so here we go. Yeah, that works. Oh gosh, everyone is shouting out their number of valence electrons. All right, so silver nitrate and sodium chloride solutions are mixed. So silver nitrate, right, Ag, NO3, silver nitrate. We know silver's a +1 and nitrate's a -1, and so that just works out, AgNO3, aqueous. Okay, and then we're mixing it with sodium chloride. Sodium's Na, chloride is just Cl-. They're always insoluble, Grayson, so there'll always be solids. Yeah, these examples will probably help to help it make sense. Okay, so silver nitrate and sodium chloride solutions, so silver nitrate aqueous, sodium chloride aqueous, are mixed. Okay, so what kind of reaction is this? Not a single replacement, Cooper, because these are two compounds, right? In order for it to be a single replacement, one of these would have to be an element. So everyone's shooting out double replacement. That's great because, again, we have two compounds. When two compounds mix, that's like our double date analogy, and so they're going to swap. So the silver and the sodium are going to switch. And so our products are going to be, I didn't get myself enough room, sodium nitrate, I'm not going to put a phase yet, and silver chloride. Okay, so what we have to do now that we haven't been asked to do because we didn't know how to do it, what we have to do now is we have to predict what's the phase of these compounds going to be. What is sodium nitrate going to be? In order to figure that out, we go up to our rules. And we say, okay, sorry. Yeah, Meredith, we'll get there. Okay, so we go up to the rules and we see sodium is on our list of soluble ions, and so is nitrate. So it's very likely that sodium nitrate is going to be aqueous. Okay, but silver is one of our exceptions. Silver is only aqueous when it's with nitrate. And so that's why this AgCl is going to be a solid. Now, I started out with a simple reaction because if you look, this reaction is actually already balanced. One silver, one nitrate, one sodium, one chloride, one chloride. Balance, balance, balance. But what I want to do is I do still want to write a total and net ionic equation. So Cooper, if something forms a gas, you'll be given more information to know that. This is just you're taking two solutions, mixing them together. One of them is going to be a solid, one of them is going to be aqueous. Can you check this? What do you mean, Lauren? With me? With somewhere in the world? Like, I mean, you could do this reaction if you had the chemicals. Have fun, Tyler. Move some treadmills. Okay, so what I wanted to do is I wanted to write a total and a net ionic equation as well. Okay, so since this is aqueous ionic, it's going to split, and it's going to split into Ag plus aqueous, NO3 minus aqueous. Sodium chloride splits into Na plus aqueous, Cl minus aqueous. Sodium nitrate splits into sodium aqueous and nitrate aqueous. But silver chloride does not split. Yeah, silver, Johnny. Let's see. Hold on. Lauren's question. I was just wondering if there's a way to know you did it right. There's not really. I mean, other than just making sure it follows the rules. That's why we have the rules. Yeah, so silver will form solids with everything except nitrate. Yeah. Okay. And then, again, I'm running out of room because I'm not doing a very good job of spacing. Okay, so then if we go from the total ionic to the net ionic, we get rid of our spectators. So which ones are spectators? Yeah, both the sodium and the nitrate. The nitrates don't change, NO3 minus on both sides, and the sodiums don't change, sodium plus on both sides. Okay, and so then our net ionic is silver plus chloride makes silver chloride. Yep, nice, clean, and simple result. So it's just what we've already been doing. Yeah, so it's what we've already been doing, but the thing is I'm giving you less and less information. So instead of me telling you what's produced, now you have to predict what's produced, right? So the idea is I'm making these problems harder by telling you less. And so it's allowing you to predict more of what's going to happen. I know, learning, it's so hard. No, it's cool. Like I hope you guys can appreciate the scientific beauty of this, because you're not actually doing these reactions, but you're able to predict what could happen. There could, Enya, there could. And so you would never really know unless you actually got in a lab and did the reaction, which we would be doing if you weren't all stuck at home. This is where this leads into like the huge lab we were going to do. We were going to spend 3 days doing like 30 something reactions, and you would be able to predict what's going to happen and see if those work. And yeah, so I'm trying to come up with some alternative that you guys could do at home. Some little, just like maybe 2 or 3 reactions you could do with some household chemicals, but I can't come up with something yet. I'm still trying to think. Okay. Okay, I think I answered all the questions. Oh, I gotta sneeze. Woo, that was a good one. All right. Good. Let's go. Let's do another example. Yeah, baking soda and vinegar, classic. No, that is a good one, but I'm more trying to think of one that would do something that we've been talking about. I can use her lab. That would be great. I mean, so the silver on the left isn't canceled out by the solid because of the phase. Yeah, that's a good observation. If something changes phase, it's not a spectator. Did you like that? Did you like that sweet mute, Parker? I'm getting skilled at this whole streaming thing. Okay, example number 2. Let's do something a little more complicated. Let's do yeah, let's do something like nickel. So solutions of nickel to sulfide. No, sorry. Nickel to chloride. And let's do potassium phosphate. Okay, hold on. There's some questions in the chat. Yeah, so Lauren, the worksheet on this is already posted. I'm going to talk about it. Yeah. And Tyler, you don't have to have so much sass. All right, so solutions of nickel 2 chloride and potassium phosphate are mixed, right? So go ahead. I'm going to give you guys like a minute or two. See if you can start this reaction. See how far you can get. See what you can do. And then I'll awkwardly stare at you. Sure. I did not like that. I did not like that. Oh, no, you beat me. Dang it. So you do have to balance them. Yeah. I do want you to write, the balance of the equation. And you have to make sure the charge is balanced and all that. Tyler, you like an adult man. Yeah, the charge of nickel can change, but in this reaction, in a double replacement reaction, the charges will always stay the same. So the nickel is going to stay as a +2 for the entirety of the reaction. That's a good question, Enya. Chloride is just plain old chlorine with a -1 charge, Ellie. The more you know. Oh. If you want to, Naomi, it's good practice. I mean, I'm going to go through them, so. The biggest thing I'm trying to hit home here is being able to predict the phase of the products and knowing how to use the solubility rules. Potentially, Zach. That seems right. It depends on where you put the um, which ones you swap. So let's do. We'll do the nickel phosphate first. Okay, so I haven't balanced the equation yet, but I did want to make sure you guys got these correct formulas. So we have nickel 2 chloride. So the nickel is a positive 2, chlorine's a negative 1. That's why our formula is NiCl2. Plus potassium phosphate. Potassium's a positive 1, phosphate's a negative 3. So that's why we have 3 potassiums. Our nickel still is a positive 2, and the phosphate is still a negative 3. Okay. And so our nickel phosphate, right, we get positive 6 from the nickels, negative 6 from the phosphates. Okay, so Ni3PO42. This is going to be a solid. Okay, I'm going to talk about why it's a solid in a second. And then potassium chloride is going to be aqueous. Okay. Yeah, nickel phosphate is going to be our solid. All right, so let's double check why we know that it's going to be solid. Because if we look at our list, nickel is not on the positive list. Phosphate is not on the negative list. And so since neither nickel nor phosphate are on the lists, we can assume that it's going to be solid. Will there always be one solid or one aqueous? There could be. So Olivia, if there are 2 aqueous, it's either going to be not a reaction or one of them might be like a weak acid or something. So yeah, so there could technically be 2 solids too. That's more of a rare reaction, but that can happen as well. But most of the time, I would say 95% of the time, when you're doing these reactions, you'll get a solid and aqueous. How do we know that those two went together, Zach or Xander? That's a good question. So the idea is that our positives are going to switch places. Okay, so the nickel and the potassium, the positive ions, are going to swap. Right? So that's why your potassium ends up with your chlorine and your nickel ends up with your phosphate. You can't say that. Okay. So, Xander, does that answer your question? Double replacement, the positives always swap. I'm glad, Tiara. Have fun. Where are you going? All right. Let's balance this equation now that we've got it written out. There are 3 nickels, so we'll do 3 nickels. 2 phosphates, so we'll do 2 phosphates. And then there's 6 chlorides and 6 potassiums, so we need 6. So 3, 2, 1, 6. Yeah. So Xander, because you're mixing 2 compounds, you can assume double replacement. So on all these assignments, all these things, all these problems that I'm going to give you for your homework and stuff, if you're mixing 2 compounds together, it's going to be a double replacement. If it's a compound and an element, that's a single replacement. If it's just a compound, that's probably decomposition. If it's just 2 elements, that's probably synthesis. Okay. Yeah. So that was a quick recap of what we did the Friday before spring break. Yeah. This is going to be due next Thursday. So homework's always due on Thursday, Lauren. Always due on Thursday nights. Okay. Let's see. In the products, I put KCl force. Is there a specific order? No, Michael. You're totally fine on that. It doesn't matter which order you put them in. It's just like math. 3 plus 2 is the same as 2 plus 3. Cool, Johnny. That's some great life advice. Put the nice phosphate first, or the nickel phosphate first, or the potassium chloride. No, I just answered that question, Grayson. I am going to do another help stream. The calendar is the same as always. Let me, right? So, So sorry that I'm not actually done, but that's just the quickest way for me to pull up the calendar. So the calendar, if you want to look at the calendar, it shows everything we're going to be doing. So we've got on Monday, we're going to do the last little bit of notes. Wednesday, we're going to do some homework help. The homework's due Thursday. And then Friday, we're going to review for the test. And then we have our test for all the stuff we've been doing over the last month is going to be a week Sunday. So, yeah, Ellie, we do need to balance it. So, oh, we already balanced it. Okay, so it's 3, 2, 1, 6. Aqueous, Enya. If it has one of them, it's aqueous. It doesn't need to have two. These examples that I've done have had two, but it doesn't need to have two. Yes, Zach, that will be the net ionic. Okay, so let's look at our total ionic. So our nickels are going to split because it's aqueous ionic. And then remember that 2 comes in front to make 6 chloride ions. Same thing with the potassium. It's going to be 6 potassiums and 2 phosphates. Nickel phosphate stays together because it's a solid. And then I'm running out of room, but we have the potassiums and the chlorides. Remember, the coefficient applies all the way through. Nickel, oh shoot, yeah, sorry. 2 plus. I don't know why I wrote 3 plus. I was looking at the coefficient. Yeah, thanks, Olivia. That was a good catch. Okay, so then if we look for spectators, our chlorides aren't doing anything, our potassiums aren't doing anything, and so our net ionic is 3 nickel, 2 plus aqueous, plus 2 phosphates makes nickel phosphate solid. And there we go. Okay, so I wanted to pull up your homework assignment to show you what it looks like. Is there more than one product like the thing that comes after the arrow? Not in the net ionic because the potassiums and the chlorides went away. But in our original equation, it's always, if we mix 2 compounds together, they're going to do a double replacement to mix 2 mores. I hope that answers your question, Jonathan. So let me pull up this. So if we go to modules, right, and you scroll down, we just finished the chapter 10 part 2. That was the total and net ionic worksheet that was due last night. We're now on to chapter 10 part 3, which you'll notice is the predicting equations worksheet. I'll also put today's stream on under this section. Okay. So we have the word and the PDF. If you pull up the PDF, this is what it looks like. Predicting equations worksheet. Okay, so what you're going to do on these problems is you're going to first write what kind of reaction it is. Which of the 5 types of reactions? Is it a direct combination, aka synthesis? Is it a decomposition? Is it a single replacement, double replacement, or combustion reaction? Okay, and then it says to write the total and net ionic if they're listed. So for problems 1, 2, and 3, you don't have to write total and net ionic equations, but for problem 4, you do. Okay. So the first one would be a direct combination. Yeah. So the first one is going to be a synthesis. So that means when you mix 2 elements, it's going to make a single compound. So this one would make magnesium oxide. This one's a combustion reaction, right? So it's going to make CO2 and water. This is a single compound plus heat. We're going to talk more about decompositions on Monday because this one's kind of special of how it reacts. But you can get started on this. So here's a good example, number 4. This is what we just worked on. This is a compound plus another compound, and you have to predict what's being produced and then do the total and net ionic equation. So there are 20 of these. So this assignment's pretty lengthy, but you can go ahead and start on it tonight and over the weekend. Just be careful of the decomposition ones. We're going to talk, there's some slight rules about decompositions that we're going to talk about on Monday, but all the other ones you should be able to do no problem. Yeah. Cool. So this is the homework. We'll go through maybe 1 or 2 of these on Monday, and then we'll do a whole lot of them on Wednesday. Yeah, so the ones with heat or electricity are going to be our decompositions, Lauren. So yeah, on those ones, hold off on those ones until Monday. But all the other ones you should be able to do if you want to get started on it over the weekend. Again, a reminder, if you have not finished the worksheet that was due last night, it's still available for submission on Canvas. Make sure you get it submitted by Sunday night. I am going to put in, for those of you that have done it, I am going to put in your scores into Skyward. So if you don't have it done yet, you might get a 0 in Skyward, but if you finish it by Sunday, I'll put it in for full credit. Tyler's realizing that there's a lot on this worksheet, I'm guessing, is what his weird metaphor was trying to say. Cooper, you don't have to do anything tomorrow or Sunday, technically. Ugh. But yeah, no, we're go until the very end. So I'm working on the calendar for next month. I'll get that together and out to you and your parents next week. So sleep this weekend, Cooper. Don't do anything this weekend. Take tomorrow off completely. Just have a good Saturday. Go on a walk. Go on a hike. Do something. I am not 100% sure how the final's going to work, Lauren. I think I'm just going to do like another test on Canvas kind of thing. It won't be a ton of points. It'll cover, we've done what, like, we'll by the end of it, we'll have done 3 units. And so we'll do kind of a test over those 3 units combined together. It'll be like that Memorial Day weekend or something. So I'm still working out those final details. But we'll just have a test on Canvas. I'm not going to do anything fancy like that. So like on the last Twitch stream you do on the last day of school, I don't know, Ellie. Probably review for your final, and then yeah. So I mean, we'll probably do review. I mean, maybe they're still figuring out what they want to do for graduation stuff. So maybe like on Tuesday or something, we'll do something fun on stream. Maybe we'll play like we'll do like some fun games. They have like the marble races or like the Jackbox games or something that maybe we'll do. Oh god, Cooper, you don't have to print this assignment if you don't want to. You can just handwrite it. I'll figure out what we're gonna do last day. I don't know for sure. Yeah, we'll do something. We'll do something fun maybe after everything's done for anybody that wants to tune in and have like a last hurrah. It would probably be on Tuesday. What would that be? Tuesday, May 26th, after Memorial Day. Right before graduation. I mean, I haven't actually given you that much on this worksheet, right? Just the reactants. So it's pretty bare minimum. So not printing this one wouldn't be too bad. Yeah. I mean, I'm trying to keep these worksheets pretty minimalistic, so if you do have to write them down, you don't have to write like a ton. So yeah, but you've got a week to get it done. We're really just gonna do, so Jonathan, to answer your question, we're gonna have a test on this next Sunday. So not this Sunday, but the following Sunday, and then we're gonna do one final unit. So really, no, Olivia, the peak for Utah COVID cases is predicted to be like May 1st or 2nd. So I would likely predict that we are going to be under quarantine until June 1st is my bet. So I'm betting June 1st is the quarantine date. So, in all actuality, I would realistically think that we're going to go till June 1st. There are some movements among some business owners and people that are starting to get fed up. So we're going to see some interesting political fallout here in the next couple weeks. So stay tuned for that. Stay tuned for some cool political fallout. So yeah, don't always don't buy into the hysteria. Most people are fine. Even with like the highest predictions, there's only going to be a very small percentage of the population of Utah is going to end up getting infected. But yeah. Earthquakes every day. We're all gonna die. The end is near. No, I know you guys are kidding. Zach brings up an interesting point. All right, I'm done for the day. We'll hit this more on Monday, and then after Monday is when you can really do this entire worksheet. So starting Monday, you can do all of the worksheets. So you can work on the worksheet Monday, Tuesday, Wednesday, and Thursday. So you've really got 4 days to work on the worksheet. Wednesday we'll go over some help on it. So Monday we'll finish up this worksheet on the notes that you need for it, and then it'll be due Thursday, and then we'll do some review and get stuff ready. Okay, so otherwise, have a good weekend, right? Try to de-stress a little bit. Like I said, go on a walk. Seriously, get outside in proper face distance, right? FaceTime people. Okay, let's stop our fun vegan conversation. But I'm out. So have a wonderful day, guys. Enjoy your weekend. I'll be in Discord this afternoon if you want to get started on this worksheet, or if you have questions from the worksheet last night. Otherwise, have a great rest of the day. Bye, guys.